speaker is Marthe Brock, CSI, CCPR, CDT, and she has been with Master Builders Solutions, which we old spec writers know as the former BASF, for 26 years. She's currently the Buildings and Restoration Specialist for Minnesota and North Dakota. She's been an active member of the local construction industry in Minneapolis since 1988, and she's past president of the Minneapolis-St. Paul chapter of CSI. She's been a certified construction product rep, CCPR, for more than 20 years. She's also an active member of the Minnesota chapter of ICRI, serving on the communications committee. Marthe has a BA from the University of Minnesota, so we're looking forward to hearing about concrete. Marthe, take it away.
Well, welcome everyone. Good morning. This subject happens to be near and dear to my heart, and it's something that I've been wanting to do for a long time. So I put together a presentation and wrote an article for the ICRI Construction Repair Bulletin on concrete curing in extreme conditions. And I'll tell you a little bit more about why it's near and dear to my heart in just a second here. If you can see me, there's a picture of a guy up here on top of my shelf, and that guy is my father. His name is Wayne Brock, and I am a second generation CSI member. Many of you know that already, but my dad joined CSI the year after Minnesota or Minneapolis charted, so he was a longtime member. He got his fellowship in the early 70s in Anaheim. Can't remember exactly what year it was, but I think it was 72 or 3, and that was my first convention. And the reason that I'll never forget it was in Anaheim, California, so I got to go to Disneyland for my first time, so it was very, very exciting. My dad is involved in this subject because he holds a patent on a product that was very influential in this market, and also helped develop a chemical product that I'll talk about as well. But today we're going to cover a handful of subjects about curing in extreme environments. And first and foremost, why cure? Why do we care? Why is it important? So we're going to talk a little bit about that. We're going to talk a little bit about how curing has evolved, and some of that evolution has come through specifications. So that's an important element to this piece. We're going to talk about the methods that are available. And there's been quite an evolution in that as well. And that's part of what I'm talking about in this presentation, is how things have evolved over the last 60 years in concrete curing. Some things have changed and some things remain the same. It's very interesting. We'll also talk about the various methods. There's lots of different ways to do curing. Talk about who's responsible for curing, when should it be done, and how long it should be done, and a few other little items as it relates to that. So first and foremost, why cure? Well, there's several reasons that it's important, but one of the main reasons for curing concrete is to retain the moisture. So you've placed a big slab of concrete and it's out in the elements, and it needs to be protected so it can hold the moisture in the slab for as long as possible. And there's a variety of reasons for that, but the big one is just to fully hydrate all the particles. So the cement particles that are in the concrete need to interact with the moisture in the water and the airborne moisture to chemically react to start the hydration process. So holding that moisture in the slab is very important. I'm going to read a quote here. After proper placement and finishing of suitable quality concrete, curing is the single most important factor in achieving a high quality slab. The retention of moisture minimizes volume change and increases durability and aesthetics. So that's kind of an overarching summary of the importance and need for curing. So strength development is something I'll talk about again in a minute here, but increased durability. So if you don't properly cure concrete, it will get dusty it will likely crack as shown in this photo. And the cracking can occur because of this volume change that happens. So when concrete goes from basically its liquid form to its solid form, there is a volume change that occurs. And we are trying to control or minimize that volume change. I'm sure you guys have seen that. It's basically called shrinkage, right? And it can be problematic in a whole host of ways. So again, curing helps to slow or minimize that volume change. And that is a very important thing for long-term durability and decreased cracking and other problems like dusting. So with that, of course, that increases or improves aesthetics, and that has become more important than ever. We're leaving concrete exposed as a design aesthetic more now than I think ever. And so having good looking concrete is certainly a design element of this, in this day and age. So that's very interesting. That's quite a shift, I would say, in my personal experience, that before concrete was like functional and now it's functional and aesthetic. So and curing is an important part of that. So just keep that in mind. And then the other part of it too, of course, is to protect the concrete from extreme conditions. And that was one of the main focuses of the article that I wrote. And in hot or cold conditions, the concrete needs a little bit of extra protection. So we don't, in hot and sunny conditions, we don't want that, again, that water to get sucked out of that concrete so it dries too quickly, especially at the surface where we need the aesthetics and the durability. So again, curing helps to slow that down. Conversely, on the cold side, if it's extremely cold, we don't want the surface to freeze because that can cause all kinds of problems as well, as you can imagine. So we're going to talk a little bit about specifications. And I did talk about specifications in my ICR presentation and in my article, because of course, specifications are near and dear to me as well. There's basically two specs out there for curing. ASTM C309 was originally approved in 1953 and has been updated periodically throughout the years. When it was originally approved, it was more of a performance-based specifications, meaning that it just specified minimum water loss. There was a level of, there's some acceptable level of water loss, but there's a benchmark where it has to be held to a certain level, and that's basically what the specification talked about. So it really was more of a performance base. As it has evolved, it has become a little bit more descriptive in that it now talks about type and class of resin. So there's a variety of different kinds of resins out there. And so now the specification is dealing with the type and the class of resin. And the reason that that kind of evolved was because in the 70s, in the early 70s, I think it was like 71 or 2, the specification changed to include this notion of membrane forming curing. So before that, in the 50s and 60s, you could spray a chemical down, and if it didn't form a film, but it held the water in, it was considered a curing compound. So back in those days, those were sodium silicates were widely used. And again, sodium silicates just chemically react with the surface, providing a crust on the surface, holding the moisture in the slab. So as the specification evolved to include membrane forming curing, those products fell by the wayside and acrylic technology came into play. So when you spray down an acrylic on fresh concrete, it forms a film over the surface, and that film provides the moisture retention properties that you need to properly cure the slab. So that was the evolution that occurred in the 70s for C309. It has been modestly updated since then. It is sort of due for a overhaul, because one of the limitations with both of these specifications that we're going to talk about is that they only really refer to membrane forming curing. They don't really address other forms of cure. So it's somewhat limited in that there's many, many ways to cure. So the other specification is ASTM C 1315, and it was originally approved in 1995. It too does have performance criteria, so moisture retention numbers that you have to hit to meet the specification. But they expanded the notion of curing compounds into this idea of sealers, because acrylics can act as a sealer just as much as they can act as a curing compound. So previously, they were really only considered cures and not really considered sealers. So with that evolution and the addition of the notion of sealers, we had to expand the specification to include things like benchmark for yellowing. If you spray down a cure and it discolors on the surface, that can make people pretty unhappy. So that was another thing that was added. Also added too was just this notion of protection against alkalinity and acid, which if you've ever had a project where you had concrete cured and they put a curing compound down, or you had concrete and then you put a curing compound down, and then you put a water-based adhesive with carpet down, and a year later or something, you pull the carpet up and you've got this stretchy adhesive that didn't cure. That's probably the alkalinity from the concrete coming up through the slab and attacking that adhesive. So it's one of those things that we learned that that can be problematic, especially if you're covering up the concrete pretty quickly. So having some resistance to that is certainly a benefit. So that was an addition to the 1315 specification. So yes, they have these specifications have evolved, but they're relatively slow to change, which isn't too surprising. Okay, so let's get into the methods. There's, as I said, a variety of methods out there to properly cure concrete. The old tried and true is water. Water is still the best curing method. It has its limitations, and we'll talk a little bit about that. Coverings have also been around forever. I have a photo from many, many years ago that shows a gentleman putting banana leaves over the top of a slab to help retain the moisture. He understood that keeping the concrete out of the wind and the sun and holding that moisture in, even with banana leaves, was better than leaving it just exposed to the elements. So coverings, again, have been around for a long time, and we'll unpack that as well. Liquid membrane forming curing compounds are probably the most common as far as types or methods available. They're pretty quick and easy and kind of a one and done sort of thing. So that's a nice thing for the contractors. And then lastly, one of the other newer methods, well, it's actually a newer, older method, is moisture retention chemicals. As I mentioned, silicates. So back in the 60s, sodium silicates were considered cures because, again, they retain moisture in the slab, and that's what we're trying to accomplish. But because they don't form a film, they got kicked to the side, and they're making a resurgence. And I'll unpack that a little bit more as we get there. So first, water cure. Again, there's many ways to do this, and there was a study done by the University of Minnesota that we sponsored with a part of the Minnesota Concrete Council that just tested every kind of membrane forming cure and different curing methods out there. And what they found is if you could take a slab and soak it in lime water, you would have the most perfect curing situation that you could possibly have. All right, well, so if you think about that, let's take a slab and soak it in a lime water bath. How feasible is that on a job site? It's not very feasible. So, but there, of course, are other ways besides just dunking the whole slab. Ponding the water on the slab, spraying or fogging the slab, or using wet coverings are ones that are commonly used. I'm going to talk a little bit more about the wet coverings, but again, the benefit of water cure is that it helps to, if you keep water ponding on the surface, it helps to slow down the heat of hydration. So what happens with concrete, as it moves from that liquid phase to that solid phase, it exotherms, it kicks off a bunch of heat. And we want to dissipate that heat as much as possible to help minimize cracking. That's so much of what we're doing in this element, or in this section of business here in construction, is trying to minimize cracking and dusting. So again, the water cure does help to dissipate the heat of hydration, which helps the concrete through the process. So the situation about water cure, ideally you want to cure a slab for 28 days. And so what ACI had decided was that if you wet cure for 7 days, and if you remove the wet curing process and apply a membrane forming cure, you have about the best shot of having a very durable slab in that condition. So that's the kind of current standard. Before, we used to just water cure for 7 days, take it off, and be done with it. Well, that doesn't always work perfectly. It's a good idea to cure for as long as you possibly can. And I know with the speed in which construction is done, that is very challenging. So that's why ACI decided that after 7 days, you can stop your water cure process and then put a membrane forming curing compound down, and you've got a really good slab. So wet coverings, basically, again, kind of like the banana leaves, but not quite that. Back in, when we first started pouring concrete, they were taking things like burlap or cotton fabric or anything that they had available that they could get it wet and put it on top of the slab. That would help keep the water in the slab. So that kind of evolved to a variety of different kinds of coverings. And so polyethylene film is still widely used. I'm sure you guys have seen that, where they just take a big piece of plastic poly and put it over the whole slab. And I've got a picture in the next slide I'll show you in a minute about that. But again, burlap had been used for many, many years. You wet the burlap down, you keep it on the concrete, and it helps retain moisture. The thing with burlap, though, is you got to keep the burlap wet. And so if it's windy, sunny, dry, whatever, you have to keep that burlap wet, and you have to keep it laying properly on the slab, because if it blows up in one area, you can get rapid drying in that area, and then that can cause cracking and other problems. So what happened, because this business tends to solve its problems pretty quickly, is they came up, the people in the field came up with an idea: why don't we take polyethylene film and burlap and put them together, and we'll call it Burline. Well, actually, Burline has been around for, 40 years at least, I'd say. And the benefit of that, of course, is that the poly helps to keep the Burline wet on the surface. So it keeps the moisture in the slab better, and then less likely to blow around a little bit and all that. So curing blankets are something I'm going to talk a lot more about in a minute, so we'll wait for that. But something else that's kind of interesting is that on vertical wall applications, if you leave the formwork in place, it basically acts as a curing mechanism, because that forming is retaining the moisture in the concrete and slowing down that hydration process. So you can imagine, like on a high rise, or say you're doing a balcony restoration, and you're forming a bunch of slab edges, leaving that forming in place it's an easy way to make sure you're getting proper retainage. And then lastly, curing paper, there's lots of different kinds. There's been a ton of evolution or innovation in this area. So the old tried and true is craft paper laminated with asphalt. And again, the asphalt was just to sort of keep it a little bit heavier and keep the paper in place. So now we'll kind of unpack each of these a little bit more. So polyethylene film is great. I mean, it's a cheap and easy. I mean, just drape it over the slab and call it good. And it has some kind of inherent advantages in that if it's cold, you can use black polyethylene film to help keep the heat in there. If it's warm, you can use white polyethylene film, and that'll help reflect. So that's really important, obviously, in exterior applications where if you've got a hot, sunny day, if you use white polyethylene film, it'll help reflect that light. So that's a real advantage. One of the disadvantages, though, and you can see in this picture, the polyethylene film doesn't lay perfectly flat. And where you can see there's little pockets of air where the poly has tented up. That's what I call that. When you see that kind of pockets where the poly is not making contact with the slab, the problem with that is that the slab will reflect that in the final finish. So when they remove this poly, there are going to be lines in that slab on the surface. It becomes part of the actual surface that shows, oh, gee, that's where the polyethylene tented up. So from the aesthetic perspective, people don't like that look, right? They want a more consistent, monolithic looking surface. So I think what's happened, really, the big challenge for us is residential concrete, like for driveways and things like that, has really become very light and white, and people expect concrete to always look like that. That is not how big slabs are necessarily done. George, did you have something that you wanted to?
Yeah, Martha, we have a question from Gerhard.
Okay.
Is there a maximum polyfilm mill thickness to consider?
Actually, I wouldn't say there's necessarily a maximum, but I would say the minimum is absolutely at least 4 mils. So, and the key to that is just that it's continuous. So a lot of times, like here in Minnesota, we'll use reinforced poly, which is more like 10 mils, just because it's a heavier duty. It's if people are walking on the slab, it's less likely to tear. And that's the other big safety problem with polyethylene film. It can become a trip hazard. So that's one of the reasons that it's lost favor. So I don't think it can be too much millage, but I think it can be not enough, and more of just the fact of the polyethylene film itself isn't as durable if it's too thin. So I'd say 4 mils is the bare bones minimum, but anything up from there is sufficient. So good. I'm glad. Thanks, Gerhard, for asking a question. I appreciate that. It helps when people ask questions. So this is the very special subject for me. My father, in 1977, invented concrete curing blankets. He holds the US patent on concrete curing blankets. So if you've ever seen an insulated blanket laying on top of concrete, my father invented that. So I am extremely proud of that. It gets me a little, and that was the motivation behind this. It's my father's passed many years ago, and I've been wanting to kind of honor him in this way. And so it's been something that I've wanted to do. And I guess there's one upside of COVID is that it gave me the time and focus to do it. So I'm pleased about that. That's one good thing. But he invented curing blankets in the mid 70s, and his motivation started from the energy crisis. So back in the day, when it got extremely cold here in Minnesota, and I'm sure from most of you too, in your regions or areas, when it got extremely cold here in Minnesota, construction would stop, basically. We would have an extreme slowdown from Christmas to April, where almost no work on the exterior was done. Now, obviously, that has changed quite a bit. And my dad, being in the construction supply business, didn't have a lot going on at that time in those days when there was no construction. So he came up with an idea on how to extend the exterior concrete placement business, so it is more year round. And that's where he came up with the insulated concrete curing blankets. So he played around with this for quite a while and tried many different things, but basically it is just polyethylene film. It's reinforced poly with layers of microfoam fiber. So thin, just think of like thin white packing foam, if you will, layers of that. Um, just sewed around the perimeter with grommets. So basically, grommets are just those round metal holes that you can. The reason for that, and this was a kind of a big deal, was you can take those grommets and hitch all the blankets together so that you're getting a good, continuous, even coverage of the slab, and it did help hold them down if it was windy. So, because you could imagine if you got a big wind going and not the blankets weren't connected, that you could get quite a bit of uplift, excuse me, and have blankets blowing around. Places like the airport, they don't like that. I don't know if you've ever had any issues with the airport and stuff blowing around, but that can be a real problem. So the grommeting was something that kind of evolved a little bit just to try to figure out how do you keep these things together and keep them on the slab. So the advantage, obviously, of the curing blankets is they're very easy to use. They're very readily available. People always ask me, so why do you work? I'm like, well, what do you mean? Well, if your dad invented curing blankets, then you shouldn't have to work. You should be like in the Bahamas. And I'm thinking, yeah, I should be in the Bahamas. But what happened with the patent was that the concept was easy enough to copy. If you just change the poly, change the foam, change minor things, you could break the patent pretty easily, unfortunately. So my dad did not make a lot of money off that patent, but he got a lot of pride from that. So that was a good thing, but I digress. Anyways, so some of the disadvantages, though, is that they're bulky and they are reusable over and over again. But in the summer, where do you store them? So, that can be kind of a hassle. They take up a lot of room. And so a lot of people don't have room on sites or room in their storage facilities for these kinds of things. So that can be a little bit of an issue. And as I said, they need to be secured so that they don't blow around on job sites. So, oh yeah, one other thing. One of the advantages of curing blankets is that you can leave them down for as long as you want. So, if it's cold and the slab isn't being used, you can leave them down there for 28 days and get all the cure that you need. So, again, it's kind of, I'd call that an advantage. So. So again, some of the advantages and disadvantages to coverings is that they are inexpensive and easy to install. You basically just drag them over the concrete surface and leave them. So pretty easy to do, pretty inexpensive. But some of the disadvantages, as I've mentioned, is windy, not great for that, but the discoloration element. So the nice thing about the curing blankets is they lay pretty flat and even on the concrete surface. So you don't get that marking that you would with polyethylene. That's one of the, again, I forgot to mention this before, but that's another one of the advantages of Burline. When you lay Burline down, it lays very flat on the slab, so you don't get those marks from the tenting of the polyethylene film. So that was a big advantage, and one reason that Burline is still widely used. So there, kind of as with everything, there's advantages and disadvantages to every type of system. But again, the big thing is that they're pretty cheap and easy to use. So. I'm going to move on to liquid forming curing compounds. I would call this the workhorse of this section of the industry. There are many types of liquid cures out on the market. These are the ones that are generally fall under that ASTM C309 specification we talked about. So my dad was part of a team in the early 70s. Again, he was very focused on curing concrete back then, to come up with an easy way, since the spec changed from silicates to membrane forming. They had to come up with an easy and relatively economic solution to that. So he worked as a part of a team to develop the first acrylic membrane forming curing compound in the 70s. And they worked on this quite a bit. There was many different types of resins tried. because one of the things that was necessary, or what they wanted, was a durable film, something that you could walk on and perform construction on, because obviously the slab's one of the earlier things in the phases of construction. So they landed on acrylic resins because they were durable. They sprayed well, which is important, and they held the retention of the water retention as necessary. So when they first started out, they were like 16 to 18% solid. So that means it had 16 to 18% acrylic resin in it, and the rest of it was basically solvent. And that was great because you could put it into a low pressure sprayer, spray it down onto the surface, and you get a nice even film. Well, as the VOC's laws have changed and as odor has become a bigger issue, they've increased the solids and decreased the solvent. There is a point of diminishing returns, though, when it comes to acrylic resin cures. About 30% solids is as high as you really want to go in that. And part of it is just for the blotchiness that you can get when you spray it down. And we'll talk a little bit more about that later. But so now the current products are generally between, about 30% of solids. So again, with the VOC laws changing and the odor issues, they decided to come up with water-based cures, water-based acrylics, and that seems like a natural transition. And water-based cures, that sounds like a great idea. It's water and acrylic, spray it down, you've got the water there, you've got the acrylic forming the film, perfect. And it is good, but it too has its limitations. And I mentioned one earlier where many of these cures, because they're not quite as durable of a film, are subject to attack from alkalinity, which with the adhesives for carpet and vinyl and such, that alkalinity can attack the adhesive and cause problems. So that was one of the challenge with water-based cures, because again, the film just isn't quite as durable as the solvent-based. And one of the reasons for that is that the water-based products don't bite down into the concrete as well as the solvent-based products do. Another challenge is what we found over the years is that solvent-based products like solvent-based products, water-based products like water-based products. They're not interchangeable. So if you try to, I've had bad experiences with trying to spray a water-based cure over a solvent-based cure, or try to use a water-based adhesive over a solvent-based cure. So keep that in mind, that again, there's a lot of variables there. So if you've ever had that issue, though, it could be that, again, that water-based products don't necessarily love solvent-based products. So white pigmented cures and fugitive dye cures. Now, if I'm assuming most of your DOTs use what we call white pigmented cures. And so basically what they did is they added a white pigment to the curing compound for help reflectance, right? Light reflectance helps to keep the heat of hydration down, and it also, helps the guy know where he put the cure. Because if you put a clear down on a hot day, you can't necessarily know where you were. If you, like, say you got, it's a coffee break, you sprayed half the slab, it's coffee time. Remembering where you were, you can't really see clear acrylics as well. So this notion of fugitive dye or white pigmented came into play. So you know exactly where you started and where you left off. And that was the reason for fugitive dye materials. But back to the white pigmented, the DOTs use them because in the study that I referred to earlier about when the U of M took the slab and soaked the whole thing, that was the best way to cure. The second best curing mechanism in that study was white pigmented cures. Again, because of the reflectance, the durable film, the different resins they use. So like, as the slide says, polyethylene is a very durable resin that is in a lot of white pigmented cures. But, and this is what I was alluding to a minute ago, they're very blotchy and yellow looking when you apply them to concrete. If you've ever driven down your highway in your hometown and you've seen this blotchy yellowish look on the concrete, that is white pigmented curing compounds. So they do not spray down very well. The aesthetic element of them is not the greatest. And of course, there's a variety of different types out there, but just generally speaking, what you see like on the MnDOT or on the DOTs is that yellowish, blotchy looking thing is white pigmented cure. Wax-based cures is a curing mechanism that's been around forever. Wax is actually a great cure. You spray down a liquid wax. It basically forms its own kind of film. It's a different kind of film. It's not like a clear acrylic film, but it does form a film, and it'll hold the water in the slab. And the easy thing about that is that wax-based cures are much easier to remove than acrylics or white pigmented, for sure. So if you want to have a cure that you can easily remove, wax-based products are used quite often. And where we see this the most probably is in dry shake slabs, where they're throwing a powder on top of the wet slab and working it into the concrete to increase durability, increase compressive, lots of different things. So we see that a lot on dry shake slabs and things like that. But it's somewhat lost favor because it's not very durable. So to perform construction on a wax-based cured slab does not work great. So they've kind of lost favor. So dissipating cures is an interesting subject. They became necessary because if you use an acrylic material and you spray it down onto the slab, it can interfere with future bond of other things, right? So that's not necessarily desirable. It would require prep to remove it and a whole lot of other things. So that isn't necessarily desirable.
Martha, we have a question from Travis Miller. Please
Sure.
describe how to remove a wax-based cure.
Yeah, so you can abrade it off real easily, but there is a stripper. The best analogy I always use is like, when you go to a grocery store and you see the guy with the floor buffer or whatever, that they were laying down a wax-based material, right? So you get enough layers on there, you end up having to strip it off. So there are very good strippers, chemical strippers that will remove wax-based cures really easily. So just think about it. It's exactly what a guy's doing or a person is doing when they're buffing the floor. They will eventually have to come back and strip that off. So it's a fairly commonly done. Tennant company has many different kinds of buffers that you can use too. So you can use like a 3M abrasive pad to remove them. They remove pretty easily. So, but chemical strip, there's a handful of different ways. But just think about the guy in the grocery store doing the buffing. That's basically the same thing, and the removal process is basically the same as well. Okay, so dissipating cures, just to get back to that for a minute. The idea is you spray down a film onto the surface, and then magically in 28 days, it disappears. And the concept is amazing. And if that worked perfectly, it would answer all the problems that we've ever had in curing. Kind of with everything, there is no panacea when it comes to that. Cures will dissipate. Any cure will dissipate with sun and traffic. So if foot traffic, vehicular traffic will abrade. These are thin films. So generally speaking, like an acrylic cure is going down about 4 mils. 4 mils, again, is sort of that benchmark that we were talking about with Gerhard. So when you spray this film down, it's going down about 4 mils. Well, 4 mils is not much. If you look at it, like a piece of paper is like 1 mil, I think, or anyhow, you get a lot of traffic on that, a lot of abrasion. Say people are bringing sand or dirt or rocks in on their shoes from the outside. That is going to scratch and start to break down cures. Well, Dissipating cures, of course, will do that as well. The challenge that I've seen, and I'm not trying to disparage any one thing because every single one of them has limitations. But the thing about what I've seen with dissipating cures is that they don't dissipate right at the wall to floor intersection or right at the column penetration that's coming through. That again, if you don't have traffic and if you don't have UV, you're not going to fully dissipate the cures. From my experience, that's what I've seen. And a lot of times when we're using something like that, you got to prep the slab anyways. Like say if you're putting some sort of polymer flooring over it, like a deck membrane or whatever, you're going to have to shot blast the concrete anyways. So it's going to take off any kind of cure that you basically have at that point. So again, the contractors love the dissipating cures because they spray them down and walk away and they never have to come back and worry about it. Nobody ever complains about the way they look or any of the problems. Now, you could get some complaints about them not dissipating, but that's really not the concrete contractor's fault, right? So, and just keep it in mind that they have their place. There's no doubt, and I wouldn't want to disparage them any more than that. So again, we'll talk a little bit more about the clear acrylics because they are the most common. There are many, many manufacturers out there, and they're pretty basic. Again, as I said, it's resin and a carrier. So if the carrier can be water, it can be solvent. So it's literally basically two components. I mean, it's a little bit more than that, but basically two components in a pail. So very, very simple, easy to manufacture. There are a variety of different kinds of resins. So in acrylic resins, there isn't just one type, right? If you've ever heard of polyvinyl acetate, PVA, that's a type of resin that could be used. Maybe not as high quality as a pure acrylic type of resin. So again, a variety of different types of resins and different qualities of resins. So, but the key really is that do they form a film, and are they going to, properly retain moisture? Where it becomes a little bit more important is if you're using the curing compound as a sealer. So what we do a lot of times, so we'll cure the concrete with an acrylic right when the concrete's placed. So as soon as you can walk on the concrete, and I'm going to talk more about this in a minute, but as soon as you can walk on the concrete, you need to cure it. So you spray that material down, and it's starting right away to retain the moisture. And then 28 days later, or even 90 days later, whatever, you can come back and spray another coat down, and then that's going to perform more like a sealer. So there may be some prep needed in between there, depending on, how the slab was protected during the construction process, or, what the circumstances are on the job. But if you use the cure at right away and then come back later and use that same cure, it'll perform really well as a sealer. Now, again, with the sealer, it's thin film and it can scratch and abrade. So again, they're not clear acrylics in this arena anyways, are not permanent. They are something that requires maintenance. So keep that in mind. A lot of people think, I'll just spray this down, we'll call it good. Well, you need to come back to it. And the best way to know if you need to is if you put a little water on the slab and it soaks right in, you probably need a sealer then. Your cure is probably gone. So
We have a question from Ron Ray. Don't dissipating curing agents require UV to dissipate?
It depends on who you're asking. That's really kind of our company's position, that if dissipating cures can't dissipate in the dark, so with no light, if they don't dissipate, then they're really not considered dissipating cures. So I would tell you personally that they need light to dissipate. So I'm not sure if I'm answering that question, if he's got a different experience from that. But from my experience, our research people say that if it doesn't dissipate in the dark, then it's not really dissipating. Okay, so I kind of already went through all this. The one thing I didn't mention was, and this is just an old tried and true material that's not used really anymore, but boiled linseed oil. That's what we used to use. And MnDOT used it for years on all of their exterior concrete. Boiled linseed oil, which basically is Thompson's water seal. I mean, not quite, but basically the same notion. So it holds water in the slab and does a really pretty good job of that. But because it doesn't it doesn't form any sort of film, it just continues to soak into the slab, so it's not protecting the surface long term. So that's why that lost favor. And besides, it's super blotchy and mineral spirits and all kinds of other things. But so one of the evolutions that's occurred, as I mentioned, way back in the 60s, silicates were always used for cures. So over time, they have evolved from the sodium silicates. Well, actually, even before that, the first silicate on the market was the early 1900s. It was a product called lepidolith that was a magnesium fluorosilicate. But the reality of the silicates is what happens is they chemically react with the concrete to form a crust on the surface. That crust holds water in the slab, and that is how it meets the curing standards. So again, the old technology, the old silicates had to react with calcium hydroxide to properly perform. Well, calcium hydroxide doesn't become really available until the hydration process has started to move along that continuum. And so they weren't really doing all that they could. So the next generation, which are now like lithium-based silicates, and there's a couple other different types. Potassium is another one. They react with the silica, which is basically the sand, in the concrete. And so you don't need to wait for that hydration process. So they've had a nice evolution, and they're really coming out onto the market in a strong way to say that they should be considered as curing compounds because they retain moisture in the slab as necessary. They should be considered cures. So, but they don't form the film, so they don't meet the current specifications. So we're in a little bit of a battle, and I'll talk a little bit more about that later. But some of the big benefits of these silicates is that they're basically have no VOCs, tend to not be a bond breaker, help control alkalinity, obviously help retain moisture, real easy to use. And so there's a lot of advantages. And that dense crust that's formed on the surface helps really improve abrasion resistance and provides a durable film. So one of the challenges, and you can see in this picture, is that the concrete decides how much silicate or how much reaction is going to occur. So the concrete will, again, depending on where it is through the curing process, it will only take so much material. And if you can see in this photo, on the right-hand side, there's a whitish haze. So and on the left, there's not. What's happened in that white area is that the product was sprayed down onto the surface, it fully reacted, and there's leftover material. So that leftover material forms this white crust on the surface that is really difficult to remove. It's a real pain. So basically, the way they do this is they'll flood the material out onto the surface. They'll let it dwell on the surface for about 30 minutes. And then they start, well, depending on there's a couple of different ways to do it, but a lot of times they'll start buffing the floor, like with that commercial grade floor buffer, to work the silicate into the concrete. And what ultimately ends up happening, if you do it enough, if you provide enough abrasion, you sort of polish the concrete. It's sort of like agates in a tumbling basket. If when you take an agate out of the Lake Superior, it's a dull, sort of not very pretty rock, but then you put it into a tumbling basket, give it some abrasion, and it becomes shiny and much brighter in color and all that other stuff. Well, concrete's kind of like that as well, in that if you put these silicates down and let them dwell for a half hour and then start flooding them and buffing them, you can pop a sheen on concrete. So you can get a bit of a sheen, and it's a durable sheen on concrete. So there's some real advantages there from the aesthetic perspective. And that's one of the reasons they're used a lot, that the sheen becomes an integral part of the slab. And so it's extremely durable. The only way that sheen really comes off is if the concrete itself wears. And because actually foot traffic and things like that can help improve the sheen, because it's more agitation. But if you start to mill down the top of the concrete, and then you're going to lose that sheen. But otherwise, it's really a pretty durable sheen. But again, the challenge with these types of products, and we're calling them water cure equivalents now these days, is that the concrete decides how much is going down. And people always ask me, well, how much do I need? And I'm like, well, somewhere between 100 and 400 square feet per gallon. That's a pretty big range. And so they're like, can't you dial that in a little bit? And I said, the concrete will dial it in for you. So some of the field considerations to keep in mind in the curing area is that low pressure spray for most membrane forming cures is the preferred method of application. A lot of people, and this is mostly homeowners, and hopefully this doesn't happen to you guys, because I've been on 1,000 driveways for this. The homeowner decides they're going to really seal up that beautiful white concrete. They want to make sure it stays perfectly white and doesn't crack and doesn't spall or anything. So they're going to really seal it up. So they're going to go and get a bunch of material and dip a heavy roller in there, or a heavy nap roller in there, and roll it all over their concrete and make sure that they've got it properly sealed. Well, great intention. Unfortunately, what happens with that is if you over apply the cures and try to get too thick per coat, it looks like a blotchy, I'd say, is it a Palomino horse? Or you'll get brown and white blotches all over the slab, and it looks horrific. So more is not better in this area. What people say to me, well, I really want to seal up my slab. Well, thin to win. 4 mils, you can do multiple layers of 4 mils, but one layer of 12 mils that is not the same as 3 layers of 4. Seems like it should be, but it isn't. And because if you think about it, concrete's like a sponge, right? Some area is going to be super absorptive depending on how you finish it. Some areas will be less. So you'll get more material in one area and less in the other. The area where it's sucking more down will tend to darken a little bit and looks like a blotchy mess is basically what it is. And it's really, really hard to remove. And what I have to tell homeowners a lot, I have to say, well, if you're willing to be patient, it will go away, because it will wear off eventually. Like I said, acrylics will wear off. So nobody ever wants that to be the answer. They hate that answer. So again, abrasion would take it off, so you could lightly blast it, or there are chemical strippers like citrus-based chemical strippers will help. There's a couple other different things you can try. We've tried, using solvent. So if you use a solvent-based cure, we've tried to use solvent to help kind of soften it up and get it to penetrate into the slab, and that works reasonably well depending on the situation. But again, a light, continuous spray with just a garden sprayer, handheld garden sprayer is the way to do it. And the roller comes into play if you have an area where the sealer has puddled. If the acrylic forms a puddle on your concrete, you definitely got to move it around, because if you leave it there, that's where you're going to get that darkening. So again, do not leave puddles in your if it's your driveway anyways. Let's just put it that way.
Martha, we have a question from Bruce Roger. Does the sealer shrink like lacquer?
Kind of. I mean, because especially like with the water-based, you're getting that evaporation, and because the percent of solids tends to not be over 30, there's a fair bit of evaporation that occurs. So there's a little bit of volume change in that regard, but not hugely. So it's not a huge problem. So again, and when in doubt, just multiple layers of thin application is best. Hopefully, did I answer that question, do you think? Hopefully I did. There is certainly evaporation loss, which does clearly provide some form of volume change, but not terribly significant, not nearly as problematic as volume change that occurs in concrete that isn't properly cured. Because if you go from a liquid to a solid really fast, you got problems. So anyways, the applied square feet per gallon, it's one of those things where I tell people to measure it out. I wouldn't put it down heavier than 300 square feet per gallon, in my humble opinion. And again, if you really want to be diligent, do it twice. That's something else to keep in mind too. If it's cool outside, do not use water-based cures. They will appear very hazy on the surface and look really crappy, and could freeze potentially too. So keep the ambient conditions in mind when you're doing these types of things. Okay, so who's responsible? This seems like such an obvious thing. Okay, the guy that placed the concrete should be responsible, right? Makes sense. However, say you're doing a water cure. The concrete guy comes and places the concrete, sets the curing mechanism in place. How often do you think that guy is going to come back and babysit that slab? Back in the old days, general contractors self-performed their own concrete work. They did their work. So they were always there. So water curing was easy to do because they'd show up every single day at the job trailer, and if they could check the slab because they're there, and it worked well. But that's not really how it is anymore, right? I mean, generally now, again, in my world anyways, there's a concrete guy, the concrete installer comes, places the slab, and you never see the guy again. I mean, because he's on to the next job. I mean, coming back to the job would be kind of not productive in a revenue area. So that's one of the reasons that we've seen some of this evolution in curing, is that the person who's doing it has changed. And so I guess my thought on that is that the conversation just needs to be had before the concrete's placed. Who's responsible? How's it going to be done? How long is it going to be done? And what are the things that need to be considered for that? If you think about it, I mean, concrete is the platform in which work exists in a building. So in many cases anyways, that it's important to have that conversation ahead of time. I cannot stress that more. And we talk about pre-con meetings and mock-ups and all of these things. I mean, especially if you have a particular client that really is concerned about aesthetics, it's a good idea to have a 10 by 10 slab placed with the mix design that you've decided on, with the curing mechanism that you've chosen, and have the owner look at it and say, okay, yeah, that looks good. That's what I want. Because concrete's more aesthetic now than it used to be, as I said earlier. So when should curing be done? I'd say early and often. That would be my standard answer. But basically, as soon as you can walk on the concrete without making foot marks, without marring the surface, you should start curing. I mean, there's no sense in waiting. Time is of the essence generally when we're talking about this. But again, with the vertical, you can leave the forms in place, but once the forms come off, it's a really good idea to take and do some sort of cure to that. Or I see this a lot in vertical concrete repair. That's a lot of what I'm doing. And they'll put a patch up there and not put a cure on it, not cover it, not anything. And it's like, you guys think that's going to be a really good idea? I mean, that seems like it should have some protection from the wind, the sun, and everything else. How long is necessary? As I said, it's changed, it's evolving, but the longer the better. You really, I don't think you could possibly cure concrete too long. I don't think that's a factor. But ACI says at least 7 days when it's above 40, and to at least get 70% of the total design strength. So if it's 5,000 PSI concrete, you need at least 70% of the total design strength of the concrete before you stop curing. That's what ACI says. So, but, and again, they've changed their tune a little bit as far as 7 days go, in that if you're going to cure for 7 days, then you should put something on over the top of it afterwards. But one other thing too, and Todd will really, Todd Johnson will appreciate this, is it does depend on the type of cement. Type 1 cement, that ASTM C150 says at least 7 days. Type 2 is 10 days. Type 3 is 3 days. Type 4 or 5 is 14 days. So again, the type of cement and the concrete mix is a factor in determining how long things should be cured. Okay, so some final thoughts. One of the things to keep in mind, and this is one of those things, again, where I've been on 1,000 jobs over my 30 years of doing this. Curing compounds will rubber burn. So if this picture is it's a forklift traffic, so it's a forklift tire. It's a slab in a warehouse where there's forklift traffic, and you can see all these marks on the surface. Well, what happens is if you make a tight turn on a curing or a slab that's been cured, you'll get a black streak on the surface from the tires. Or if you park your forklift and the tires are warm, you'll get that transfer. That basically it's a plasticizer migration from the tires onto the slab, and it too is a pain in the neck to get off. And people are always like, "Oh, your stuff's failing; it's turning black," and blah blah blah. No, and that's why I use this picture. Is that clearly that the thing in the middle of that photo is a forklift tire. I mean, so I have gone round and round on that before. But something else to keep in mind too is most like silanes or silicates or whatever will not penetrate through curing compounds. So you have to remove them if you want to put something like a penetrating sealer in there. So just keep that in mind. Also, one last thing too, do not leave curing compound ponding in joint sealants. Like a lot of times they'll do a joint sealant that's concave and you'll get a puddle of material in there. Don't leave that there. That needs to come out. They need to at least come back and back brush that or whatever. We don't like to leave puddles when we're talking about cures. So, whew, okay. In summary, I made it. Curing is absolutely critical, and hopefully I've given you that. I've made the case for that. It can be very simple, but it can be a hassle too, and it can require having to come back. And so sometimes it's skipped. People don't realize that it's important as it is, or just don't want to be hassled by it, so they skip it, and that can be a huge problem. And curing is evolving, so the silicate world is coming after us membrane forming materials, in that because they retain moisture, they want to get in part of the business. So I think that the evolution that's occurred over the last 50 years, 50 or 70 years has been significant, and there's more to come. So that is it. And I went over by one, sorry.
No, that's fine. If we don't relate at CSI, we're not doing our job. We have a couple of questions at the end here. Would you mind taking them now?
Sure, yeah.
Kermit asks, are there contractors?
Wait, no, Kermit's not allowed to ask questions. I'm kidding. Okay, go ahead.
Kermit asks, are there contractors that use pre-task planning to address the concrete curing issue?
Boy, I hope so. I guess I'm not 100% sure of that, but it's a great idea. I mean, yeah, it's because, see, that's the thing with curing. Again, it seems like, oh, it's that one guy's job. No, it really, if you think about it, because everybody's working on that slab after it's placed, it's kind of everyone. But it's a great idea. I hope that that's being done.
And Gerhard asks, what additives tend not to be compatible with curing applications?
Oh, you mean admixtures?
He said additives, but
yeah, probably admixtures.
I would think so.
You know, I don't. know if there's any specific admixtures that don't work with cures. Now, of course, there's admixtures now that are part of the curing process and like the moisture retention arena. I don't know if Todd Johnson is on and could jump in on that, but I don't know that there's actually any admixtures that don't work with acrylics. I guess that would be something that you do in that meeting ahead of time and discuss the mix. That's a good question. I don't really know for sure, but I don't think there is any. I guess from the silicate perspective, you got to have something to react with, and I mean, the ones that react with silica shouldn't be a problem, but there's a lot of different admixtures out there these days, but I think generally speaking, they're pretty compatible.
Okay, we have a question from Ron Ray. Since the mix design is a factor in the required curing time, should the entity preparing the mix design also recommend a curing time as part of the mix design submittal?
That would be ideal. Yes. Yes. Because again, like for me, I don't get to be, or I guess I shouldn't say get, but I'm generally not involved with the mix design side of it. I'm coming in after that's been decided. So I think, and meaning that I don't know what types of cements are being used. Of course, I can ask her, I can look at the printout or whatever, but I do think that these ready mix guys are extremely sophisticated and definitely know the best way to handle their concrete. So, I mean, I do think that is a good idea.
And since you did not want a question from your Minneapolis St. Paul buddy Kermit, I'm going to ask you if you will accept the final comment from Sheldon Wolf.
Not him. Yes.
Sheldon says, it seems we know how to minimize concrete problems. The problem is they take more time and they cost more money.
Yes, yeah, exactly. And that's why it gets ignored, is that, if you do it, I mean, it doesn't have to be expensive and difficult, but it can be. And again, I think it depends on the conditions, but absolutely that, the reason it's skipped is because it costs money and is a hassle.
All right, Martha, thank you very much. And thank you all for attending. We're going to have about a 10-minute break. Thank you, Martha.
Thanks, guys. Thank you.